We have to be on our best behavior at this point.
You got
And watch out, Jess, is it Mississippi over on this side of Mississippi?
Alright, so let's go ahead and start. Again, this is pretty straightforward for the most part. I think you guys are going to do really well on this quiz. It starts off with observational study versus experiment. Okay? So, remind me. She might not want your pencil, Jonas.
No.
Yeah, I know.
Okay.
Alright, so here's the deal. When you have to choose between whether a study is observational or experimental, remember there's one thought, and that has to be, did you provide the treatment? Did you cause the treatment? If you didn't cause the treatment, then it's observational study. But if you caused the treatment, if you gave the treatment, then it's experiment, okay? So this question is not asking us, should it be observational study or experiment? It's asking us if it is or not. So all we got to answer is, did we cause the treatment? So look what it says. You want to know if reading to children every night before bed affects the age they begin reading on their own. You choose families who read to their children every night before bed, and choose families who do not. You record the age children in each group begin reading on their own and compare. Now, is that observational study or is that experiment?
That's observational because you're observing.
Exactly. Well, you observe in both, but the difference is, am I giving the treatment? Are you walking into certain people's houses and reading to their children?
No.
No, this is definitely not an experiment. This is observation. It would be.
Mm-hmm.
Walk in, the child's just a regular person.
Yeah.
I see the cat's hand right there.
So this one is definitely not experiment. You'll be able to tell if you're giving the treatment, then it's experiment. If you're not giving the treatment, it's just something that's going on and you're observing it, it's observation. All right, next one. Remember, you get to use this review on the test. So the first thing I would like you to go ahead and have written on here are your percentages. Does anybody remember what they are?
34,
34,
13.5,
13.5,
2.35, and 0.
2.35, and 0.15. Now again, if you don't recall that, here's how it worked. 68% was one standard deviation. Well, that's two sections. So 68 divided by 2 is 34. So both of these two are 34. Then two standard deviations is 95%. 95 minus the 68 that already is gone is 27. So the next two spots have to be 27%. Well, 27 divided by 2 is 13.5. Three standard deviations is 99.7. Well, 95 is already gone. So 99.7 minus 95 is 4.7. So those next two little slivers is 4.7%. Divide that by 2, that's 2.35. So that's where those come from. And then you got that little bitty 0.3% that's left. Well, 0.3% for two sections is 0.15 each. So both of these on the outside are 0.15. Please write those in. That way tomorrow you don't have to worry about percentages. You got them there, okay? You get to use this review on the quiz. All right, now for this particular problem, it says that a number of homes, or a number of days, a group of homes is on the market is normally distributed with a mean of 50. Pause. Where does that 50 go? Right smack dab in the middle. That's our mean. That's our average. Then it says it has a standard deviation of what? 13. Well, what do I do with that 13?
You add, and you go right and then subtract.
That's right. You add 13 when you go right. So what's 50 plus 13? What's 63 plus 13?
76.
And what's 76 plus 13? And then when you go left, Jackson says you subtract it. So what's 50 minus 13? 37 minus 13? And 24 minus 13. So these are for this particular group of data, These are my specific areas. We've got to mark. 50 is your mean, and then you add and subtract that standard deviation in both directions. Now you can answer any question they ask about it. Okay? Now, please be careful and not do what I made a mistake of doing on the notes. Remember that day? If it says what percent or what proportion, it is asking about tallying up these percentages. But if it says how many people or how many homes or how many trees or whatever it is you're talking about, you're actually talking about the percentage times the total. So let's look at this problem. The first question says what? So between 11 and way over here at 89. So what are my two good options here? Anybody?
You subtract 0.3 from 100.
Okay. You could subtract the two that are not highlighted, 0.3 from 100%. Say it louder. You could remember that 3 standard deviations is 99.7. Or the last option, couldn't you add all the ones that are highlighted? I mean, that would take a little bit more time, but you could go 2.35 plus 13.5 plus 34 plus 34 plus, okay, you could do that. Either way, you're going to get 99.7%. 99.7%. Okay, next question. It says, what is the probability, remember same question, percent, probability, same question, that a house is on the market for at least 37 days. What does at least mean? That's the minimum. 37 is the minimum. So it can be everything from there over. So once again, 2 really good ways to do this. Go. You could add 50, right? Because isn't half of this 50? So you could add 50 plus 34. No, that you're just talking about all the highlighted area, so it would be all of that. So what is 50 plus 34? So 84%. And then what would the other option been? You could subtract the ones that are not highlighted from 100. You could have added all the ones that were highlighted. Okay? So either way, 84%. Last one that says approximately how many homes were on the market between 37, there's 37, and 63, there's 63. Now what's the key to this problem? It says how many homes, right? They don't want to know percentages, they want to know how many homes. Well, how many percentages is this? It's 68%, but it's 68% of how many homes? 250. I told you in your instructions. So we want to multiply 250 by 68%. Guys, how do I write 68% in my calculator? So go 0.68 times 250. That's how many homes. So what do you get? So about 170 homes. So just be careful on a question like that where they want an approximate value. You got to take your percent and multiply it by your total. Okay? Yeah, it's doable. All right, so there is all the questions for that particular normal curve. Now go to the next one. It's another normal curve. So what I personally would do is I would either erase these or just write under them, and I would remember that isn't it the same percentages? So I'm not changing my curve at all. I'm just changing this problem to have a mean of what? 17. And then it has a standard deviation of what? 4. So what's 17 plus 4? 21 plus 4. What's 25 plus 4? Okay, go the other way. What's 17 minus 4? 13 minus 4? 9 minus 4. That's how easy we just changed from one problem to the next. Now, what does this one ask me? what percent, right? Just percent. What percent are between 5 and 13? That's these two groups right here. So, how do I tally those up? Yeah, just add them. What's 2.35 plus 13.5? 15.85%. You're going to miss the instruction. But go ahead. This is a review for tomorrow. Sorry.
How did you get 13.5?
Well, remember, it's that. Yeah, it's our little percentage here. Okay. Now, we then move to the next side, the other side, and we jump back into the exact problem we were just doing. And I promise you guys, on the test, or the quiz, tomorrow, your values will be straightforward ones like these, where you just type them in. You don't have to worry about doing years from. It's just whatever you have here, that's what we're going to do. So see how it says use a scatter plot to figure out what it is? That's what we're going to do, okay? Now, here's my recommendation. Don't you get to use this review on your quiz tomorrow?
Yes.
So maybe you even write some of these key presses down on your paper, okay? So let me remind you how we do this. First, remember your calculator, there's a good chance tomorrow it will have been reset, right? There's a good chance it will have been reset. So, first, personally, and you don't have to do this, but I like to go to mode, and remember what I like to turn on? The stat diagnostics. That way it'll tell me how closely my graph matches my data. So I like to turn that on. You don't have to do that, but I like to. So now we're going to go to Stat, Edit. Stat, Edit. And we're going to enter those numbers. 1, 2, 3, 4, and 5. On the right side, we got 4, 6.8, 8.1, 9, and 9.5. Okay, so we've got our data entered into Stat, Edit. But now we got to see this graph, right? Well, remember, your calculator just got reset probably. So you got to go turn your stat plot on. So remember how to do that? We go second, y equals. Second, y equals. And that very first thing, we make sure it says plot 1 on. Well, mine doesn't say plot 1 on, does it? So I want to turn that on. So push enter and turn it on. And here's the last thing. Now you want to view your data. So what did we say you push to view your data? We push zoom. Guys, we push zoom. And we do zoom stat, number 9. Zoom stat. So we do zoom, zoom stat. And it's going to zoom in just on our data. Now, hopefully, you remember those sketches that we did. If you don't, maybe even put the sketches on this note sheet, right? I see some curve. Now, exponential either does this where it starts flat and goes steep, or it starts going down and goes flat. This one starts by kind of going up and then it goes flatter. Which one was that?
Logarithm.
This one's logarithmic. You can tell it has a curve to it. See how it starts by going up and then it kind of flattens out? That's logarithmic, okay? So maybe you get the note sheet out from yesterday and you just do quick sketches of what those look like. Of course, lines you probably know, they need to be pretty straight without a lot of curvature. Quadratics I think you're probably pretty comfortable with too, right? They either are U-shaped up or down. But the ones that you might have a harder time distinguishing are exponential and logarithmic. So maybe you sketch them on your piece of paper here. Now, last thing, once I figure out it's logarithmic, I'm going to run a regression test. So where do I go to do that? Stat, scroll over to calculate, And we're going to run not a linear, that's linear, number 4. Not quadratic, that's number 5. Not exponential, that's 0. We're going to run a logarithmic one here. Logarithmic. LN. So you do a bunch of entering, and then voila, here you have it. Here's my equation. Huh? Yours don't have the R's? Okay. So remember, if yours don't have the R's, it's not a huge deal. That's that stat diagnostics thing I was telling you about. The reason I like to have R on is because when I look at R and I see that it's 0.9959, I'm pretty confident that this matches a logarithmic function pretty good. Because remember, the closer it is to -1 or 1, it's like a dead match. So this is a pretty good match. Yes?
Which menu would we need to go into in order to get the R and R squared?
Okay, go to mode. If you want the R to be there, go to mode and turn your stat diagnostics on.
There it is. Thank you.
And now when you go run your LN reg, it'll be there. Okay?
Awesome. Thank you.
No problem. Now, here's my equation. So, it's logarithmic, right? We said. And my equation is y equals, what's A?
4.18.
4.18 plus, what's B?
3.45.
3.45 ln of x. So let me go back to my page. So if you didn't write these, you can now write them. So it's logarithmic, and my equation is 4.18 plus 3.45 ln of x. Remember, your regression gives you the equation. You don't have to memorize all that. It's there. Now, what's the last thing we got to do? Predict. What will it be at 15 years old? So what do we do to predict that?
Plug in 15.
So go to your calculator and go 4.18 plus 3.45 times ln of 15. So let me go back to my calculator. 4.18, and I'll go back to that in a second, so hang tight. 4.18 plus 3.45 ln of 15. So I get about 13.52. So here it is. So y'all can get this written down. It's logarithmic. There's the equation the calculator gave me. And there's the prediction that I got when I plugged 15 into it. Again, as long as you know all those key presses, this problem will be just as easy as this tomorrow, I promise. Okay? Now, the next two problems are both pretty simple, so let's finish this up. Number 9 asks about margin of error. See, it tells me the top 100 male weightlifters were tested on the bench press. They averaged 515 pounds. The margin of error is 10. So they want to know, what would I expect the population mean to fall? Well, here's how you do it. It's like standard deviation. You take your average and you subtract and add your margin of error, right? So what was my average? What was my average here?
550.
So subtract 10. What's 515 minus 10? 505. And then add 10 to that. What's 515 plus 10? So I can be confident that my population mean would fall between 505 and 525. Okay? Pretty strong guys, huh, Kobe? All right, last one has to do with population proportion. And hopefully you guys recall the day that we did this. Population proportion is when you set up a fraction. The top number is the specific category they ask about. Does anybody remember what the bottom number is? It's all of them, total. So type in your calculator quick, 20 plus 30 plus 16 plus 45 plus 34. Total them up. 145. Now, let's read the problem. What is the estimate population proportion of the least preferred subject. So this one is specifically asking about the least preferred. Well, what's my smallest value here? Science at 16. So type in your calculator 16 divided by 145. 0.11. So I would take 0.11, or what else would I take? I would take 11%. What else would I have taken? I would have taken 16 out of 145. Any of those are telling me that you know what you're writing, okay? So I would have taken any of those three. 0.11, 11%, or 16 out of 145. And that's it, guys. Now remember, if you want to take the quiz tomorrow with this review, you've got to have this review with you. If you don't bring this review back, you can't use it, can you? All right, so please tuck it away somewhere safe, so tomorrow it'll be with you when you come back and take this little quiz, okay? All right.
You ever press 515?